Hi, my name is Tim Carter. I know what you're thinking. You're thinking, gee, is this what we have to watch for the next 15 minutes? This is so lame. I agree. This is lame. Now it's time for the real video. Hi, my name is Tim Carter with P&S Paving. I'm here today to share with you a change to the standard specification that our team helped to develop. So we've all been there. We've paved our roads, we've had our inspections, only to find out that we have deficiencies from the rolling straight edge that indicate low areas on the roadway. We feel that we can repair these areas without having to put 100-foot patches in the roadway, full lane width and full depth. I think I speak for all of us when I say that we don't want to spend any more time or money than we have to. So we set out to change that. I've been in this industry for 36 years. Being in construction, well, it's kind of my childhood dream. I dreamed of one day manning those trucks on my very own, and every construction job and worker were my hero. The idea just fascinated me. The reality is, I got stuck doing the paperwork side of the job. No, it's fine, it's okay. I handle the crew and the money, so the pressure's on me and not the machine. In doing this job, I've had many setbacks. Like when the rolling straight edge gives me a bad reading and I gotta spend tons of time and money fixing a mistake that's not even there. Yeah, right here was the spot where I lost my Christmas bonus. Yeah, they said I had a low spot in my asphalt when it was really a high spot. Why do they talk bad about my asphalt? I got perfectly good asphalt. There's nothing wrong with my asphalt. My asphalt's flat as a pancake. I knew something needed to be done, not just for me, but for my fellow asphalt brethren. So it is true, whenever the rolling straight edge reads a low spot, when we all know it's actually a high spot, it costs us so much time and money. So I wanted to demonstrate as to why this keeps happening and what I think we can do to prevent it. So this is an example display our team made. We went down to Hobby Lobby and purchased some material and made, to scale, what the process looks like on any given project throughout the entire state of Florida. I apologize for not painting and building the surrounding area to scale.
Please excuse the crudity of this model. I didn't have time to build it to scale or to paint it. It's good. Oh, thank you.
One of the biggest issues we have while we're paving is trucking and keeping a consistent flow of material from the trucks. Unfortunately, when the trucks become separated, oftentimes the paving machine must stop and wait and wait and wait. So during this period, the sheer weight of the screed itself invites gravity to do its thing, and the result is the screed settles a bit more into the fresh, hot mat. So when the trucks do resume, the paver hopper fills and the paver takes off. Now, the screed acts like an airfoil on a plane and begins to rise underneath the new material. This rise is short-lived as the materials begin to settle out through the machine. So the result is a temporary dip and a temporary high spot. This scenario plays out more than any other during paving, and although there are other factors that can affect smoothness, this scenario is by far the most prevalent. So, all of the following scenarios involve the quality control technician pulling the rolling straight edge behind his truck at a very low speed, and the owner's rep, the inspector, riding behind, observing the behavior of the needle. So this is the 15-foot rolling straight edge. The distance between the two axles is scaled to 15 feet. The rigid straight edge also matches the scaled 15-foot distance from axle to axle. A wooden dowel was also used to simulate the indication needle of the rolling straight edge. It's graduated in 1/16 inch increments and is also color-coded to demonstrate tolerances that are in and out of specification, just as the real indicator would do. The metal shims are scaled to 3/16 of an inch. To demonstrate calibration, we'll place two 3/16 inch shims under each axle. The dowel reading should now read 3/16 inch low, which it does. Now removing the two shims and placing one shim underneath the indicator, the rolling straight edge should now read 3/16 inch high, which it does. Now the rolling straight edge is calibrated. I'm going to show you three different scenarios we have presented to the FDOT. This first one shows how a low rolling straight edge reading is caused by a high spot. The rolling straight edge is being pulled down the subject lane and the needle is reading steady at 0. The rolling straight edge reaches the area where the screed settled. The first thing that happens is that the front wheels of the rolling straight edge dip down into the low spot caused by the screed settlement. The needle will briefly read a short high, but nowhere near being out of the spec limit. As the rolling straight edge moves forward, the front wheels now encounter the high spot created during takeoff and they begin to rise. So much so that the needle now falls sharply into the dip created by the settlement and reaches into the red zone. The inspector honks his horn indicating to stop. The rolling straight edge is moved back and forth to assess the extent of the deficiency. As the rolling straight edge now moves forward once again, the front wheels clear the high spot and begin to move down back to level condition. And now as the needle itself crawls out of the dip, it will now indicate a slightly high condition along the peak of the high spot. Not necessarily out of tolerance, however, so no high deficiency must be recorded. If the rigid straight edge were employed at this point, keeping in mind Florida Method 5-509 prohibits its use, it would become clear that the high spot is the root cause of the low reading on the rolling straight edge. Simply placing the center of the rigid straight edge on the top of the high spot and a 3/16 inch shim in the low area will show that there is significant distance in between the leading end of the rigid straight edge and the map beneath it. Here's what our team presented to properly locate a true low spot. The rolling straight edge is pulled down the subject lane and the needle is reading 0. The rolling straight edge front wheels encounter the low spot and the needle briefly reads a high condition but not out of tolerance. As it continues moving forward, the front wheels encounter the same flat plane as before the dip and the needle drops into the dip to the point of entering the red zone. The inspector once again honks his horn indicating to stop and assess the situation. The rolling straight edge is pulled back and forth to examine the extent and a low reading is recorded as a deficiency. The use of the rigid straight edge at this point, placed on center of the low reading, will reveal little to no distance along the leading end of the rigid straight edge, differing greatly from scenario 1, and thereby confirming the existence of a true low condition. So our last scenario example shows how to detect two high spots in succession. The rolling straight edge is being pulled down the subject lane and the needle is reading steady at 0. The front wheels reach a high spot and rise up at the peak of the high spot. The needle briefly reads a low condition, but not out of tolerance. The front wheels go even plane again, and the needle reaches the peak of the high spot, but the needle does not read out of tolerance. The rolling straight edge moves forward, and now the front wheel reaches the peak of the second high spot, and the rear wheels are also resting on the peak of its high spot. The needle now shows a low condition and enters the red zone. The process stops and the rolling straight edge moves forward for extent. Both the front and rear wheels of the rolling straight edge descend from the peak of the high spots, and now the rear wheels reach the peak of the second high spot and read high, but not out of tolerance. The rolling straight edge moves forward back to flat plane, and a load deficiency is recorded based on the needle indication from the rolling straight edge. The rigid straight edge placed on center of each high and a 3/16 inch shim placed between them will clearly show a significant distance between flat plane of the mat and the tip of the rigid straight edge. This would indicate the presence of a high, just as in scenario 1. So the bottom line is, highs in the vicinity of lows or a succession of highs will yield misleading readings from the rolling straight edge, and the contractor pays. Our team spent months fine-tuning and giving our presentation to anyone who would listen. Wives, co-workers, pets, small children, the boss, anyone who would offer an objective opinion and poke holes in the presentation before it was officially presented. Nevertheless, the department agreed with us, but rather than changing the method and the governing specs, they offered a more global solution. This new solution will allow all paving contractors in the entire state to choose for themselves how deficiencies will be corrected prior to the final paving layer, knowing that once they get to the end, they are ultimately responsible for the rideability, thereby saving money otherwise spent on needless corrections. Our team was very satisfied with this outcome. I also serve as the chairman of the Specifications Committee for the Asphalt Contractors Association of Florida. So I brought the idea to them and they agreed this was a good move. So here we are today, giving this presentation.